All right, in this lesson, we're going to be talking about circuits. So in the last video, we talked a little bit about electricity, specifically what it is, how it's consisted of voltage, current, and resistance. Then we talked about alternating current and direct current. Now we're going to talk about circuits. Very important to understand this before we get into the next lesson. So when we're talking about circuits, we're going to have series and parallel circuits. When it comes to a series circuit, this is going to be a single path for current to flow. And in a conventional circuit, your current is going to flow from positive to negative on the potential. So for our battery right here, it's going to go from positive to negative. We're going to have one consistent flow. Because current is flowing in one path, all the devices you add is going to have to share or split the voltage. So if this were to have 24 volts, and we have two devices here, these are specifically our lights, then this device is going to have 12, and this device is going to have 12. It's split because it's only going to be able to go in one direction. Now, current, however, is going to be the same between both the devices. We're going to talk in a second about how resistance plays a role in this circuit. When it comes to a parallel circuit, we actually are going to have multiple paths for current to flow. So when we're coming out here, we can go down this path or this path. Because we have separate paths, our voltage does not have to be split. It's actually the exact same. So on this circuit right here, for 24 volts, you're going to have 24 potential at each one of these lights right here. Whereas our current is going to be split between it. Now, when I talked about resistance, this is because we need to understand power. So very quickly, what power is power is your voltage multiplied by your current. So if you have a voltage of 12 and you have a current of 2 amps, then you're going to have a wattage of 24. So it's important to understand this because power is the actual consumption of what's being used in a circuit and for the devices. So you have devices that require a certain amount of power in order for them to work. This is very important. And because series circuits, not only does it reduce the initial voltage that each device is getting, but every time you add a device, you're increasing the resistance of that current to make it through. Whereas, because you're adding more devices and more paths to flow on the parallel circuit, you're actually lowering the resistance. So, in a parallel circuit, you're going to have more power potential than in a series circuit because you're going to be having more resistance. And as we know to Ohm's law, if you increase resistance, you're going to lower your current or voltage. So it's very important that, because we're looking at power, which is voltage times current, if we're lowering resistance, we're going to have lower power. If we're increasing resistance is lowering power. Lowering resistance is increasing power. So it's very important that we understand this when it comes to our power and our consumption. Now, what else does it mean though? So when it comes to a series circuit, if something were to happen to this device, right? If this device were to not work, this one's not going to work either because you're blocking the flow, right? So if you were to have 10 devices in a row and your very first one fails, all 10 are going to fail. And that's the problem, is if you come over and you see 10 devices are failed, now you got to figure out which one was the break. Right now, typically the very first one you're going to check and you're going to go from there, right? Last known source of power. However, when it comes to a parallel circuit, if this device were to fail, this one's still going to work because it has a separate path. So there is a lot of pros over parallel when it comes to, doing a series circuit. So anytime you're going to be in a warehouse industry, almost any kind of circuit you're going to be dealing with is going to be a parallel circuit, because you're going to have a lot of heavy devices between motors and sensors and your VFDs and all that stuff. So you're going to want a parallel circuit because you're going to need that voltage to be applied to everything equally. You're going to want more power. And because you have so many devices running on a control panel, you're not going to want to increase the resistance by adding these devices because now you're working against yourself. You're going to have to increase the power, and you just don't want that. It's not optimal. So it's very important to understand that whenever you're going to be calculating your power when it comes to your consumption and adding devices, because they're going to behave differently. So I hope this makes sense. Very quick breakdown on circuits when it comes to what series is, what parallel is, what the difference is, and again, power, voltage. I'm going to write that down up here. So let me erase this real quick so we can give a little refresher on this. Okay, so it's very important to remember, power is watts. And then power is specifically voltage times current, okay? And that is going to be our consumption. So when we're talking power, this is what you're going to be using. If you see 200 watts, 400 watts, 1,000 watts, right? In order to calculate if you're going to be able to support that device, you need to understand your voltage, your current, and your resistance. Because remember, that's going to affect your current. So it's important. That's why we had to talk about voltage, current, and resistance before. And now we can talk about power and the circuits and how it plays a role. If you have any questions on circuits, leave it down below. In the next video, we're going to be talking about schematics and symbols, and we're going to start to break down more complex circuits.